So first of all, I want to make sure that you download all of the attached diagrams. I need to get comfortable with the diagrams, because when I'm going to make use of those, both from when I'm going to explain technologies and when I'm going to also show live demonstration of the technologies at the CLI, then I need to know the topology and the IP addressing. So the first PDF file is going to be the physical topology. This is the physical topology for IINS CCNA security track. I'm going to make use of that, and what that means is that we have certain of those. So it's going to be a lot of switches in here, a lot of routers. You can scroll down through it. We're not going to make use of all of them, only a few of them. But of course, you got to know how the routers, how the firewalls, the switches are being connected at the physical level in order to understand some of the topics in there. Then we have what is called the main diagram, which we're gonna use portions of this diagram to show up specific topics like the ASA firewall, the iOS firewall, the IPsec VPNs, and the AAA protocols and things like that. So if you go, for example, at the main base diagram, then you see we have 4 routers: router 1, router 2, router 3, and router 4. Also, as you're going to see, we're running in here end-to-end EIGRP routing protocol. In initial configuration files which are attached to the class, you're going to see that we're running end-to-end EIGRP in here to provide routing. The only device which is not running EIGRP from the initial configuration files, it is the ASA firewall, because we're going to lively do the EIGRP implementation and OSPF on ASA, also with authentication as securing the routing protocol. So the ASA doesn't run EIGRP from the initial configuration files. We're going to do that ourselves within this class. Now, likewise, pay attention to the IP addressing system. Like in general, for example, if you pick up VLAN 23, which is between router 2 and router 3, it is in the format of 136.1.VLAN number, which is 23.0/24. And then each device in general has an IP address which equals with the device number. Like router 2 is going to have a .2 IP address in here. You can verify that in the initial configuration files. 3 is going to have a .3 address in here. Likewise in VLAN 13, 3 is going to have a .3 address, likewise, and 1.1. The only exception is going to be that the ACS system has a .100 address. Test server likewise .100, and test PC is going to receive an address via the HTTP. Then you have this is the router-based diagram, which we're going to be using extensively, and mainly it's a subsection of the main logical diagram. We're going to make use of this when we're going to speak about, for example, whatever has to do with the routers, like the control plane, the management plane protocols. We're going to make use of this diagram. The reason that I have multiple diagrams is because the main diagram, it has too many devices. So when I'm going to go ahead and also draw on the diagram, is going to become convoluted and difficult to follow up with. Then you have what is called the switch-based diagram, where I have purposely configured switch 1 in here at the layer 2 level, because we're going to speak about in here about some specific topics, some layer 2 security topics, and I need to understand exactly how TSPCA, which is in the same VLAN as router 2, how they speak with each other, which is via switch 1. So in pretty much all of the diagrams, like if you look up at the main diagram or at the router base diagram, all of the links deployed on a diagram, like this one, this one, this one, this one, and the other one, the last one, those are layer 3 links. So this shows you the layer 3 topology, not the layer 2 topology. The only exception is on the switching diagram, which likewise this is going to be a layer 3 link, this one as well, this one as well, this one as well. Those are layer 3 links, but at the same time we have these two in here which are layer 2 links. Because we're going to speak in there, as I was saying, about some layer 2 topics, and I want you to visually see how the switch stands in between, and we're going to see exactly what we're going to deploy at the switch level to protect the network from specific attacks. Likewise, at the this is the ASA base, where I'm using the ASA in this diagram, which we're going to go in here, and as I was saying, we're going to configure EIGRP, both authenticated and non-authenticated, and OSPF as well, with the same option, both authenticated and non-authenticated. Likewise, we're going to speak about also on the SA briefly about the AA part, which is going to be the same thing which we're going to be doing also on the iOS routers. And finally, we have the IPsec section, the IPsec diagram, not section, which is going to be used to configure or basically implement IPsec VPNs between, for example, router 1 and router 2. We're going to do in here LAN to LAN IPsec VPNs. For the SSL VPN part, we're going to do it on this diagram. We're going to make use of this. We're going to make sure that, for example, test server A can initiate, for example, a SSL VPN session to the ASA, which is type of remote access, and then gain access to specific resources which are behind the ASA. Okay, so there's a question from Dimitri. Hi Christian, I noticed that for IP addresses used on IPv4, why not IPv6? Because I think in the previous blueprint there was IPv6 in the blueprint, but for the current one, which is version 3.0, no more. We're going to look together at the blueprint. I've also attached the PDF document about a blueprint on the course files. So CISCO removed IPv6 from the current version. Now you might state, okay, why is that? Because IPv6 is gaining more and more, let's say, deployments. It's getting more and more, people are getting more and more used to IPv6 and are starting deploying IPv6. If you ask me, that was a good call, because basically IPv6, so when a transition from v4 to v6, everybody said it's going to be just plug and play, which technically is not the case. It was only a marketing term, because it's a lot of things that are different in IPv6 than IPv4, and also from the application point of view there are some differences, but most notably from the layer 3 point of view. So you can imagine that at the CCNA level, they would have put it in the exam in here, the basics of IPv6, and this is this is a security exam, right? So now basically they should have added in here, you should have known how IPv6 works, which is very different how IPv4 works, and then they should have added in here IPv6, let's say, security topics. So what are the challenges with IPv6 from the security point of view? But as I was saying, from my point of view, it makes sense that I have removed this, because there's not enough room in the current course, let's say, not format, but within the 5 days course, is not enough time to put a lot of things in there. And from my point of view, it's better to put fewer topics but cover them better than throw a lot of topics and just scratch them at the surface. So it makes much more sense for me, even though of course it is bad at the same time that it is an emerging technology, not technology, an emerging let's say technology you could set in the internet, and at the same time is not being touched at the CCNA level.